or electron devices. If you are not able to understand, I will explain to you again. Please unmute your mic and talk to me.
Ma'am, it's clear, ma'am.
Okay. So the same thing is explained with the support of one symbol. Okay, this is a symbol of transistor. You know, this is an NPN transistor. N, P, this is N. Okay. So from P to N, always current flow is there. Okay, it is the conventional current direction, not from N to P. So this is your terminal of, symbol of the transistor, and the connections are connected in such a way that the exact connections are shown. VBB, positive, negative. This side also positive, negative, like that. And current, you see, IB, IC, IE. IB is the base current. IE is the IC is the collector current. Sir, good morning. I have class now. I'll call you, sir. Class, okay, sir, right. So IB is the base current, IE is the collector current, then IC is the collector current, and IE is the emitter current. Okay, so here, what is VBB? VBB is the base voltage, or you can name it as VBE also. Nothing wrong in that. Able to follow me? VBE. What is VBE? What is VBE, boys?
Ma'am, VBE.
Voltage across base and emitter.
Emitter.
Or we can name it as VBB also. Nothing wrong in that. Okay.
Okay.
The meaning of this is voltage at the base with respect to emitter. Okay, because the emitter is grounded, right? So voltage at the base. This is the base. This point is B. So even you can represent this as VBB, no problem at all. The meaning of this is voltage at the base with respect to emitter is VBE. Okay. Or else it's a base voltage. Normally with respect to the ground only we will be calculating. So it's VBB. Right. Similarly here you see at the output this is going to be C. This is C and this is your emitter. Okay. This is VCC. Even you connect, you can consider this as VCC or VCE. Both are same. Okay. Any doubts here? You please ask me.
Ma'am, please explain again VCC.
Yeah. At the input side, you know, at the input side is base. See the exact replica of this left side diagram. Left side circuit is shown with the support of the symbol of transistor, nothing else. Okay, instead of the bar-like structure, only we have drawn the transistor. Transistor has 3 terminals. You know, this is your emitter. This point is emitter. Okay, and this is your collector, and this side is a base. So in the input side, we have represented the voltage as VBB. Even that can be rewritten as VBE also, because it is nothing but voltage across base and emitter. Similarly, at the output side, you have the collector, right? Collector and emitter. Even if instead of VCC, you can name it as VCE also. Okay, both are same. Why both are same? Whatever it may be, we are going to measure the voltage at collector with respect to E. So VCE, potential difference between collector and emitter. That is the concept. Potential difference between collector and emitter. Here, voltage across collector we are considering. Understood? Okay.
Yes, ma'am.
Now, similarly, now come to the bottom. So here NPN is shown, but here PNP is shown. Okay, the whole current is flowing through the device. So it's a PNP transistor. As I told already, N is your base terminal is marked here, and this is going to be collector and emitter. Since it's a common emitter configuration, emitter is common to both the input and output. Accordingly, we can represent the input voltages. Input voltage may be represented as VBE, exactly similar to the previous one. Okay, that may be either VBE or VBB, nothing wrong in that. Similarly, at the output side, it may be represented as VCC or VCE. Okay, and the current flow, because of the application of the potential, here holes or the majority carriers, they may be repelled by the positive term of the battery, and the holes will be moving like this. Okay, while moving towards the collector, what will happen? Few of the charges will be recombined with the electrons. Okay, and recombination will be taking place or nullified, and few other holes will be going towards the negative term of the battery. Okay, these are holes. This is your conventional current direction, which is exactly equal to the direction of flow of holes. So you must keep a few things in mind. Okay, direction of conventional current is opposite to the direction of flow of electrons. How current will be flowing. If there is any flow of charge carriers, current will flow, isn't it? You can feel. You cannot touch. Can you touch the current? No, you cannot feel the current. But we can measure the current with the support of ammeter, or we can measure the voltage with the support of voltmeter. That's all, right? So here, what will happen? Yeah. So here, whole current will be flowing through the circuit, right? The direction of whole current is same as that of the direction of conventional current. Then few of the holes will be crossing and they are moving towards the collector. Okay, and they may be attracted by the negative terminal battery, right? And the flow of holes is like this. So it is exactly similar to the direction of flow of conventional current. The same thing is same circuit is redrawn using the symbol of the transistor. Okay, now see, this IB is going out. You can see this is IB, and IC is like this, right? Current direction is very, very important. And similarly, this is your emitter current. Okay, yeah. Here also, whole current is flowing. So the same thing only. Okay, if it is flowing through the emitter, that is called emitter current. If it is flowing through the base, that is called base current. If it is flowing through the collector, it is called collector current. That's all, right? For all these cases, IE is equal to IB plus IC. Say, for example, if you consider this as a point, okay, and there are 3 lines if you draw, right? So this is your IB. IB is going out, then IE is going in, IC is going out. Outgoing current is equal to incoming current, or IE is equal to IB plus IC. This equation is satisfied. Understood? So this is what you can explain the current flow with respect to the configurations of transistor. We have discussed about what is CB, common base transistor. Okay, and also we have seen what is common emitter configuration. Okay.